Hello friends, I am Shivaji Sonone. Welcome to the class of physics. In this video, we'll see PN junction diode, its biasing, forward biasing, reverse biasing, IV characteristics of diode, and one of the important application of diode as a rectifier and the Zener diode as a regulator. So first one, that is the PN junction diode. What is meant by PN junction diode? When P type of semiconductor and N type of semiconductor is get joined together, the resulting arrangement is known as PN junction diode, or it is also known as semiconductor diode. So see here, this is the P type of semiconductor in which the majority carriers are holes, and N type of semiconductor in which the majority carriers are electrons. When these two semiconductors is get joined together, the junction is formed, and this is known as PN junction. In the PN junction, in the P type of semiconductor, the majority carriers are holes, and the minority carriers are electrons. Then in N type of semiconductor, the majority carriers are electrons, and the minority carriers are positive holes. When PN junction is formed, the P region has a majority carriers holes, and the minority carriers these electrons. Similarly, in the N region, electrons are the majority carriers and holes are the minority carriers. And when this junction is formed, this junction is electrically neutral. Then when a junction is get formed, the positive holes from this P type of semiconductor and electrons from the N type of semiconductor is diffuse across the junction to the opposite side of the junction. And due to this diffusion, there is a recombination of electrons and holes, and there is a formation of this region, and this region is known as depletion region. Here, what happen actually when the PN junction is get formed? The holes from the P region is diffuse in the N region due to the difference in concentration. Similarly, the free electrons from N region diffuse in the P region due to the difference in concentration. Holes and these free electrons get combined near to this junction, and each recombination eliminates an electron and hole. The uncompensated negative immobile ions in a P region do not allow any more free electron to diffuse from N region. Same thing, the uncompensated positive immobile ions in the N region then do not allow any more holes to diffuse from the P region. So the positive donor ions in the N region and negative acceptor ions in the P region are left uncompensated. So what is the result? The region containing the uncompensated acceptor and donor ions, and this region is known as depletion region. Since the region which having only immobile charges, so this region is also called as space charge region. N region is having high potential than the P region. So the electric field is set up between this depletion layer, and the difference in potential between P and N region across the junction, it is difficult for the holes and electron cross the junction, and this potential difference across the junction is known as potential barrier, and the distance between this junction or the two sides of this junction is known as width of the barrier. So potential barrier for silicon is 0.7 volt and for the germanium it is 0.3 volt. So potential barrier opposes the motion of these majority carriers, and due to this opposition there is no flow of current through the PN junction. However, the few majority carriers with kinetic energy overcome the barrier and cross the junction. And this potential barrier helps the movement of minority carriers. So for the motion of these electrons and holes, it is necessary to apply some external voltage across this junction. And this external voltage or this concept is known as biasing or PN junction. And there are two types of biasing known as forward biasing and reverse biasing. In the forward biasing, what happens? This is the battery external source of energy, and when this positive terminal of this battery is connected to the P region and negative terminal is connected to the N region, then PN junction diode is known as forward biasing. And in case of forward biasing, the depletion layer region or this width of depletion layer is very small. What is the reason behind this? The holes in the P region are repelled. The holes in the P region are repelled by the positive terminal of battery, and the free electrons are repelled by the negative terminal of battery due to the repulsive force. And due to this, these holes and these electrons are moved towards the junction, and the width of depletion layer decreases. Therefore, the large number of majority carriers diffuse across the junction due to this repulsive force, and the whole current and the electronic current are this, or the electron current, this IH current due to the motion of holes, and this IE, the current due to the motion of electrons, are in same direction, and these two currents are get added. Once they cross the junction, the holes in N region and electron in the P region become minority carriers of the charge and constitute the minority carriers. Then in the P region near to the positive terminal of the battery, the electron break covalent bond in the crystal, and this hole is get created. So this hole is get drift towards the junction and electron enter the positive terminal of the battery. Thus the current in the external circuit is due to the movement of electrons and the movement of holes. If the applied potential across the junction, external voltage get increases and the potential barrier further get decreases. As a result, the large number of majority carriers diffuse through the junction and the current is get increases. This is the concept of forward biasing, and in the forward biasing, current is maximum. This current is in milliampere. Then second type of biasing is known as reverse biasing. What is meant by reverse biasing? In the reverse biasing, the negative terminal of battery is connected to the P type of semiconductor, and positive terminal of the battery is connected to the N type of semiconductor. This type of biasing is known as the reverse biasing. In this reverse biasing, the holes in P regions are attracted by the negative terminal of the battery, and electrons in the N region attract towards the positive terminal of the battery. Thus, the majority carriers are pulled away from the junction, and due to this, the potential barrier as well as the width of depletion layer get increases. Therefore, it becomes more difficult for the majority carriers to diffuse across the junction. But the potential barrier helps the movement of minority carriers, and as soon as these minority carriers are get generated, they are swept away by the potential barrier. Then at a given temperature, the rate of generation of minority carriers remains constant. So, in case of this reverse biasing, the current through the circuit through the PN junction is very small. The number of minority carriers is very small. The current is very small, and this current is in the order of microampere to nanoampere. Microampere through the germanium and nanoampere through the silicon diode. In the reverse biasing, PN junction diode has an effective capacitance called as the depletion capacitor. P and N region act as the plates of capacitor, electrode of the capacitor, and the region, a depletion region, act as a dielectric medium. So we'll see the IV characteristics of PN junction diode in forward biasing and in a reverse biasing. In case of forward biasing, here this is the PN junction diode is get connected with the rheostat or the variable potential source, and milliampere is connected for the measurement of current. Then voltage applied across the PN junction is measured by using this voltmeter. Then what is the IV characteristics in forward biasing? So what happens when this external voltage across this PN junction diode is get slowly increases, initially up to the barrier potential, up to the new voltage, current through the circuit is equal to 0. But when external voltage is equal to and greater than new voltage, then the current through the PN junction diode is sharply or linearly get increases. This is the linear region, and this voltage at which current get increases is known as mu. Second type of biasing is known as reverse biasing. In the reverse biasing, this external voltage is connected in opposite direction, that is negative terminal to the P region and positive terminal to the N region. Microampere is connected to measure the current in reverse biasing. So in case of reverse biasing, due to the maximum width of depletion layer up to the maximum voltage, current is equal to 0. Current is equal to 0. But when this voltage is greater than this breakdown voltage, then the breakdown takes place, and the voltage at which breakdown takes place is known as breakdown voltage. And at the breakdown voltage, current is get increases, sharply increases, and this current is maximum, it is in microampere. So resistance of diode in forward biasing and in a reverse biasing. So resistance is equal to voltage upon current, or you can say that change in input voltage per change in current through the diode. In forward biasing, current is where this resistance is very small, but in the reverse biasing, resistance is maximum. So another one application of this PN junction diode is known as rectifier. So what is meant by rectifier? The device which convert AC voltage into the DC voltage is known as a rectifier. And there are actually two types of rectifier. One is known as half wave rectifier, and second one is known as full wave rectifier. In case of half wave rectifier, one transformer is there. This is step down transformer, and this step down transformer is connected to the single PN junction diode in forward biasing, and this is the load resistance to measure the output voltage. Input voltage is applied across the primary of this transformer voltage. So the process of converting alternating current into the direct current is known as rectification. Then the device used for the rectification is known as a rectifier. So PN junction diode offers a resistance, low resistance in forward biasing and high resistance in reverse biasing. So there are three steps. In the first step, when this terminal is positive and this terminal is negative, then in this case this diode is in forward bias and current is going to this PN junction diode. So for this positive half cycle, you get this positive half cycle. But when negative half cycle is applied across this first terminal, then this diode is in reverse bias. Current is not going through the circuit and output voltage is equal to 0. So for the full sine wave, for the full half cycle, positive and negative half cycle, we get the output only for the positive half cycle. So this type of rectifier is known as half wave rectifier. Second type known as full wave rectifier. In the full wave rectifier, there are two types by using the 2 PN junction diode and by using the 4 PN junction diode. By using 2 PN junction diode, so this is the transformer and the 2 PN junction diodes are connected at the output of secondary of this transformer, and this output voltage is measured across the load resistance. Again, similarly, like as a half wave rectifier, we'll see the two cases for the positive half cycle and for the negative half cycle. When the diode rectifies whole of AC wave, it is called as full wave rectifier. Means when the output is for the whole sine wave is known as full wave rectifier. During the positive half cycle of the input AC signal, diode D1 is in forward bias and diode D2 is in reverse bias. Then the current is going to the circuit and output voltage is going back to the load resistance. So we get output voltage for the positive half cycle. Then when the negative, during the negative half cycle, the diode D2, this is the negative half cycle, diode D2 is in forward bias and diode D1 is in reverse bias, and in this case the voltage is developed across the load resistance due to the diode D2. So in full wave rectifier, we get the output voltage due to the positive half cycle as well as due to the negative half cycle. So this type of rectifier is known as full wave rectifier. Another one type of diode known as Zener diode, it is specially purpose PN junction diode for the regulator as a stabilizer known as Zener diode. Same like as a PN junction diode, Zener diode consists of P type of semiconductor and N type of semiconductor. Junctions are get combined, only one difference, these PN junction are heavily doped. This is the symbol of Zener diode. The depletion region, it is less than 10 raised to minus 6 meter in the Zener diode. The electrical field is very high and it is 5 into 10 raised to power 6 volt per meter. This Zener diode, when connected in forward biasing, the IV characteristics of this Zener diode is same as the IV characteristics of PN junction diode in forward biasing. So this Zener diode is, when this Zener diode is connected in reverse biasing, initially this current is very small, but at the Zener breakdown, the current through the Zener diode remains constant, and due to this property, Zener diode is always connected in reverse biasing. And this Zener diode is used as a stabilizer, it is used as a regulator. Then we'll see the circuit diagram of Zener as a rectifier. To understand this, unregulated power supply is applied across the Zener diode with the series resistance to control the current, and this Zener diode is in reverse biasing. Then the output voltage across the load resistance is remains constant, or we can say that regulated voltage at the output. So this Zener diode is used as a voltage regulator, means with respect to increasing input voltage as well as load resistance, then also output voltage is remains constant, is known as Zener diode as a voltage regulator. So V in, suppose this is the V in is the input voltage, then this V in is equal to voltage across the series resistance Vs plus voltage across the Zener diode, that is the Vz. According to the Kirchhoff's law, V in is equal to Vs plus Vz. As well as suppose total current is equal to I, then across the junction this current is get divided through the Zener diode and through the load resistance. So I is equal to Iz current through the Zener diode and IL current through the load resistance. So this is a specially purpose junction diode known as Zener diode, and this Zener diode always connected in reverse biasing as a voltage regulator. Thank you.